Hey guys, hooray, the Dumont RA113 is finally done, so I'm going to move on to some other projects, or maybe I should say move back to some other projects. First thing I want to do is tune up and talk about some test equipment. I'd done a part 1 a while back where I'd gotten some new Sencore equipment, in particular PR57 and LC53, and I want to include some other bits and pieces as well while I'm at it. But before I do that, just some quick updates. One, the Sonora Portable has been identified. It's a model 663. More on that coming up soon. Here's a little picture tube from it I've already taken out. 2, I'd mentioned the Fluke15DX, which I will be getting to as soon as this stuff's cleared off. Well, I got some new speakers a few months ago, and I'll tell you right now that the output transformer appears to be bad on those. So the fun continues with that endless project. Alright, so first thing I want to take a look at is the PR57. Works fine, I've been using it in lots of videos recently, but whenever I turn it on, there's a hum. And I've heard other owners say that they do not have that hum. I'm thinking it's just something mechanical. Like the power transformer isn't bolted down securely, I can see it right down in there. Or maybe I'll just live with it, but regardless, I've never looked inside this device, so I think I should, just to make sure that there aren't any bad caps or resistors or anything. I just never noticed that there's a handle on the side of this, which is kind of nice for carrying it around. I've just been kind of picking it up with both hands and moving it around. And then on to this guy. If you recall, it seems to work on capacitance fairly well, but I did not get the probe with it. Since then I've picked up some low capacitance coax that I'll try fabricating a probe from, and the inductance side just does not work at all. I'm not going to spend a whole lot of time trying to fix that. I've seen the service manual, it's freely available for download. There's a lot to it. I don't want to spend a couple weeks trying to fix this when it's something I really don't need. I've rarely, if ever, needed to actually measure the value of an inductor, and as far as doing ringing tests on flybacks or yokes, I've got like 5 other devices that can do that function fine. So I just want to focus on getting this squared away, because as much as I like using that solar capacitance bridge, not the most convenient thing to use. Moving on, I did a restoration video on this a while back. Works fine. In fact, it works so well, I want to use it more often. Lately, I've been using this for doing alignments. Well, I want to find a spot to put this. In general, I want to rearrange all my test equipment. I've done enough projects now that I know which pieces of equipment I use all the time and which I do not. So definitely some reordering is in order. Like this guy, awesome piece of equipment. I spent a lot of time replacing about 100 bad tantalum capacitors. But now that I got this, which can do more of the type of stuff I need, it's kind of redundant. So I think that will go into storage. I'll sell it off or something. And similarly, awesome VTVM, maybe the best there is, but this has a nice big meter on it, and one of the best features of this is it can measure RF AC up to several hundred megahertz if you have the original probe, which I do not, and I really don't need to measure AC that accurately. I can just use my scope, so it's another piece of equipment I don't use too much, and this whole area should get rethought, I think. Alright, but for now, let's focus on this. I found the PR57 manual online, downloaded it, and checked out the section disassembly, and as near as I can understand it, they said remove the 2 screws above the handle, then flip this thing so the other side is up and remove all the screws, and then the top and this side should pull it off. Now on this side they say to remove 5 screws, all the screws except the 2 that hold the top on. So the idea is, there we go, the side and the top come off as one piece. Alright, so there it is. Not a whole lot to it. Oh, and I did unplug this, by the way. So, big isolation transformer, and then here's the control part. So somehow this interacts with this to make a variable isolation transformer. Unfortunately, I don't see really anything that I can tighten down. All these screws seem to be pretty tight. But now I'll try plugging it in and give a listen and see if I can figure out exactly where the humming is coming from. I'm guessing it's this. So it might just be the nature of the beast and just the laminations inside are vibrating and there's not a thing I can do about it. And then under here is where the active electronics are. There's not a whole lot to it. So there's two screws you remove from the underside and you get this cover off. Kind of sounds like the hum might be coming from over here. So I was curious, it's not load dependent, so right now I've plugged in this device. I turn it on, no difference in the hum whatsoever. Here's what was under that metal shield. Basically a bunch of power resistors and some diodes. And this is how it does the current and voltage sensing. So like that curly Q there with a wire soldered on it. That is the 4 amp range current sense resistor. I guess if you want to calibrate it, you have to unsolder that little wire and then move it to another position. And then there are trimmer pots for other ranges. I'm not going to mess with any of that. As far as the hum, I still cannot tell where the heck it's coming from. As I'm pushing this, I still think it's coming from over here somewhere. But I've tried pushing on this board and the connectors and all that, and it's nothing obvious. I don't want to like grab this and electrocute myself. I think the best thing for me to do is to just put this all back together and just use it as is before I break anything. Obviously the thing works fine. There's no obvious loose connection or damaged component or anything like that. Well, at least it was interesting to see what's inside of this and to verify that the condition is fine. As far as caps go, there's only two. There's a little electrolyte down there, which looks okay, and a little mylar here. It's probably okay because, as I said, this thing works fine, so there's no sense in inviting problems by trying to remove this board and mess with any of that stuff. Alright, so that's it for the PR57. Now, if you're wondering about this leakage test, well, mine didn't come with the probe, so I can't use it, but I'm not really concerned because it's not something I really would be using too often. And what that's for is for a hot chassis set like the Sonora. So one side of the AC goes right to the chassis. Usually they have the hot side. I can find where the AC input is on this thing. There it is. One side will be switched, and one side goes to the tube filaments. Usually they switch the side that goes to the chassis. So when you close the switch, turn the power on, one of these two AC prongs goes right to this metal. And then it's in a metal cabinet. Now if they just bolted this chassis to the cabinet, you pick that thing up, your other hand brushes against something that's ground, like a light plate switch or a water faucet or something, you would get electrocuted. So what they did is they use little plastic standoffs. So the metal chassis should never come in contact with the metal cabinet. So what you can do with this leakage test is you'd plug this thing in here, you'd take your probe and you'd probe around various parts of the cabinet. and there should be no leakage. It measures in microamps. It should be really low, or 0 ideally. But typically what I do on these is I rewire them and use a polarized cord so that the chassis is neutral. So even if this was to come into contact with the cabinet, you should not get shocked. Anyways, that's what that's for. If I could find the probe, it'd be nice, or I suppose I could fabricate one, but not too worried about it. Now, as I was plugging this back in, it occurred to me there's something else that I was long overdue, which is to do something about my power strip situation. I just have this Belkin floating around here, and I keep swapping cords around. What I really need to do is to get a longer one and permanently mount it somewhere up on here, maybe like on the underside of the workbench, so I can keep all this stuff plugged in. Right now, I think only my scope is typically plugged in, and the others I just swap them in and out. Like this guy is going to this right now. And I don't have enough outlets to plug all this stuff in at once anyway, so that's been kind of an irritation. So next time I'm out at maybe the Home Improvement Center, I'll look around online, I'll see what solutions they have. I do recall seeing one. It was in a long metal channel. I had quite a few outlets, and it was thin, so you could like possibly maybe mount it up here. It was a little expensive, but it looked like it'd be something really ideal for the situation, better than say just a plain old computer power strip. In many of my older videos, you'll see me using this Mastech MS8268 digital multimeter, which I don't think is even made anymore. Good all-around meter if you can find it. It has a lot of extra bells and whistles. Like it actually has a frequency counter, and it can measure capacitance and diode check and check transistors and the usual, of course, of volts, ohms, and amps. I think it was $55, something like that. It's fused. It's can do up to 1,000 volts. And I've used the heck out of this thing, and it's still working great after 3 or 4 years. But I know there's more robust meters out there. One of the real things that drives me nuts about this meter is after about 10 minutes or so, it beeps and turns itself off. Doesn't matter if you're using it or not. As long as you keep it in the same mode, it turns itself off. Maybe there's a way to extend that period other than just switching modes every 5 or 10 minutes. But it's like I said, it's getting kind of worn out, and it's not the most accurate thing. Pretty accurate, though. Certainly more accurate than, say, a VTVM, especially if you want to measure resistance or a precise voltage. So anyways, that led me to this. I always wanted to get a Fluke anyways. And this one in particular, Fluke27, yeah, it's long in the tooth, and it's pretty big and chunky, but it's really, really built well. I found out about this from watching a YouTube video at the EEV blog. If you just go into YouTube and search for Fluke27, I'm sure you'll find it. I opted for the FM version, the militarized version. But not only is it gray versus yellow, the FM version also has true RMS. Now what does that mean? Well, most meters, unless you're measuring a perfect sine wave, you're not getting a true accurate RMS reading on the voltage, like a triangle wave, a square wave. If you used a meter like this, you would get a value that was not what they call the true root mean square of the voltage. This will. Doesn't do the fancy stuff though. No frequency counter, no capacitance, but that's alright. Now check this out. If you open this up, this can be calibrated, but I have not chosen to do so yet, and this is why. This is a precision Tel Labs resistor, 0.1% accurate, 1.111K. Check out that reading. That's why I like to use this for checking resistance. Got another one here, 0.05% plus minus 1 kilo ohm. You can't beat that. Something else this has that's kind of nifty is a bar graph along the bottom. So as your input resistance or voltage varies, this goes back and forth. So if you want to do, say, an alignment using this, it is possible. Normally using a digital voltmeter for alignment is a pain, because as you're tweaking the core, the numbers don't update that fast. They'll just be flashing between various values. This will actually move back and forth fairly quickly, and you can watch for the, when it goes over furthest to the right, that's your peak. And it's got a few other things, like you can do hold and min-max, so you can lock in a value and then take another value and do an offset or comparison. But anyways, another nice thing about this is, if you look inside, I'm not going to pop mine open, but there are a lot of safety features, some pretty hefty fuses, over voltage protection, so it's not only accurate, but it's a safe and trusty meter to have. Now, I opted for the version that came not just in this carrying case. Oh, and by the way, ton of these on eBay because of military surplus. His warranty expired in 1989. I'm not sure when it was last calibrated. I imagine probably back in the late 80s, early 90s, and you can see how good it still is. Well, along with this meter came this guy. It's a high voltage probe. Basically, it's two resistors. Form a voltage divider, and you plug this into the meter. This is only good to 6,000 volts, though. So maybe on something like a VT71 electrostatic set, you're kind of pushing the upper range of it, but you could probably get by using this meter. So I looked around and I eventually splurged and got this guy, which is the 40,000 volt version of it. It's the 80K-40 high voltage probe. Mine at first was giving me really funky readings, and I finally figured out by unscrewing this and examining it that the solder connection to the tip had broken loose. I just touched that up, and that's been working great ever since. I'm not sure exactly how everything's supposed to fit together in this case. I believe the meter goes here. I mean, that part I could figure out, and there's a little strap that goes over it. But as far as the probes go, I don't know. It came with this one. I think it was just thrown into the side, but there's nothing to hold it down. It doesn't really lock into anything. Like these notches down here don't correspond to the handle. Doesn't really fit up here, so I don't really know how all this stuff's supposed to go. I don't know what's supposed to fit into all these compartments exactly, and this doesn't fit in here so well. So the case is of somewhat dubious value, but with the meter out of it, because I'm always using it, both probes will fit inside, so at least it's handy for that. Now here's a look at something I promised to do a video on way back when I got it months ago. Never got around to it, so I figured now's a good chance. This is a Wavetek 183 swept function generator. I think it'll go up to 20 megahertz. A function generator, what I mean by function is it'll do like trigonometric functions or mathematic functions. So it'll do sine wave, triangle wave, square wave, and you can tweak any one of those. Like with the symmetry controls, you can turn a triangle wave basically into a ramp, either ramping up or ramping down, and you can turn a square wave into a narrow or wide pulse. Alright, so that seems simple enough. You dial in the frequency here, range, pick your output, square, sine, triangle, and output level. This will do a pretty hefty output. 50 ohm output, you can do like plus minus 15 volts or so into 50 ohms, but you can actually drive a load even lower than that. This is an 8 ohm speaker. Now you don't want to burn out the amp on this though. They're pretty pricey and kind of hard to replace, so be careful. But if you treat it right, you can put out some decent power from this. That's a basic operation. You've heard me use this before. This is the device that will do the whoop whoop sounds. Okay. Now the reason I'm doing that is because here's a normal function generator. But this is a swept function generator. So if you put this on sweep, it's just like a sweep generator, like if you're going to line a radio or TV. This sets the sweep width. Go all the way down, it doesn't sweep at all. Higher you go. That's setting the sweep width, meaning you go from, so you start out from the center frequency and you go to either side of it, wider and wider and wider and wider and wider. Sweep time. Sweep very slowly from the low to high frequency. Very quickly from the low to high frequency. And here's how you can set the two frequencies, the start frequency, the stop frequency, and then do it continuously. And there's a manual trigger mode. I don't know exactly how that works, but there's a way where I think you can just, every time you push this, it'll sweep. Various attenuation modes, which is nice. Now, let's look at high enough for frequency. You could use this for aligning an AM radio. This will do 455, no problem. And like I said, it'll do a 50 ohm output, which is a lot more power than you need to align an AM radio. So maybe I'll try that sometime. But that's not all this can do. You may have noticed this yellow, or this light up here, and this XCG. It took me a while to figure out what the heck that was all about. This has a phase lock loop crystal reference inside of it. So normally when you're dialing in this frequency, you know approximately where it is. You can check with a frequency counter or a scope. And it may drift a little with temperature over time. But you go into this is crystal lock. This will lock on specific frequencies. When that light is lit up, that means you are locked into a specific frequency. But it will only go in certain multiples. Like it'll do 440, 450, 460. So you can't lock into 455, which was kind of something I was hoping I could do with this, to use it for alignments. So for the kind of work I do, not particularly useful, but it's a neat feature to have, and it's pretty darn accurate. Accurate to as good as your crystal is, so certainly more accurate than just guesstimating off the dial or looking at a scope and guesstimating the frequency, that's for sure. Something else I really like about this is the way it's made. It's from the late 70s into the early 80s, and they used all off-the-shelf parts on a couple giant circuit boards. So very easy to repair, except maybe for that output amplifier. Unlike Hewlett-Packard, where it's all, well, first off, everything's house numbered, but even if you can figure out what those house number parts translate to, often there's some more exotic stuff, or sealed modules, and the replacements can get kind of expensive. This, piece of cake to service. Even the cabinet that this is in is readily available off the shelf. I remember using these back in the 80s to make projects. Bottom, top, plastic shells, front, back aluminum panels. Alright, so here's the insides. Turns out that when you take the screws out, the bottom folds down. On the other side of this is just all the, it's just the underside of the board. There are no parts on it. So this is the main function generator. There's all the analog stuff. This is the digital crystal reference board. So basically it's a phase lock loop built out of discrete components. Somewhere on here, there it is. There's the crystal reference. Little capacitor trimmer for calibration. Alright, it's from 77. See all the date codes. So this is all pt2o logic on here. Low power Schottky series, like LS90 decade counters and kinds of goodies. So there's where, where it will plug in, so this could be taken out. And there are other models of this. I think there's a probably a 181, a 182, 183, and a 184, I think, of various options. And here's the analog part. So this is that amplifier I was referring to. I think those are specially chosen transistors, NPN and PNP, that are matched to give a nice clean output. And you can see the switches actually mount right onto the circuit board. Kind of a nifty construction technique. All the other parts are all readily available, you know. Just there's our TTL logic chip, so some transistor arrays, tip 29, tip 30, power transistors, bunch of discrete transistors. So if you need to repair any of this stuff, just order up these parts anywhere, no problem. Luckily, I didn't have to. When I got this, it didn't quite work right. It turns out that I think there were some chips that were loose. I just had to go down in here and just mush all the chips back into their sockets, and things started to work just fine. This video is getting kind of long, so I'm going to break it off here and pick up in the next installment with the Sencore model LC53 capacitance and inductance analyzer.